Welcome to the BC Technical webinar series. We will be discussing the imports and exports of Dicom, networking, and troubleshooting in nuclear medicine. Today's webinar session is worth 1 voice credit, and in order to receive this credit, you must complete the online test, which is available immediately after this webinar. A passing score of 80% is required for the voice credit to be awarded. You may take the test more than once if need be, and a certificate will be emailed to you at the close of this webinar and following successful completion of the online test. Please keep this certificate as proof of your completion of the webinar. If you haven't noticed, computers are everywhere in nuclear medicine. Whether you are scanning a patient, checking out a dose, or processing a study, there is one common theme. The nuclear medicine field has been taken over by information technology. Whether you work in a physician's office or a large hospital, you spend part of your workday importing, exporting, or archiving Dicom information via networks. The typical nuclear medicine workflow starts with a patient registering and the demographic information sent to the modality work list through an HIS-RIS, which is a hospital information system, or a radiology information system. Once the patient's exam information is available, the nuclear medicine acquisition computer registers the patient's demographic information and begins the scan. After the scan is completed, the study is exported to a post-processing computer for any study-based results or processing. After post-processing, the study is transferred to a PACS for storage and for physician interpretation. Now, this workflow is a generic model of what happens before and after a patient study, but you can see how information is transferred electronically via every step of the workflow. Digital imaging and communications in medicine, aka Dicom, is a standard for handling, storing, printing, and transmitting information in medical imaging. It includes a file format definition and a network communication protocol. The communication mode used is the TCP/IP protocol. Dicom files can be exchanged between two entities that are capable of receiving image and patient data in Dicom format. You may want to research more on this topic by checking out the website on this slide. Every piece of medical equipment that is Dicom compatible has its own name, address, and zip code. The name of a medical device is called the AET or AE title. It stands for Application Entity Title that is unique, so no other medical device can use that name in the same network. The second defining characteristic is the device's address known as an IP address. This is a numerical label that identifies the device, such as a street address. And the third piece of information is the port number, which acts like a zip code. Some institutions have different zip codes because they are very large and share a lot of data. So port numbers help keep data in the same networks so traffic doesn't slow down. A computer network is a telecommunication network that allows computers to exchange data in the form of packets. Networks are connected through Ethernet cables. There are other devices used in the network configuration worth mentioning, like switches, hubs, and routers too. Since this PowerPoint is for nuclear medicine technologists, we are going to elaborate on what is typically found in a nuclear medicine room. This is a typical nuclear medicine camera room network. We have listed each part of the network with a letter and will explain their role in the workflow. HIS-RIS stands for Hospital Information System or Radiology Information System. They each mean the same thing. First, the patient will check in with admissions. During that time, the office personnel or the technologist will electronically enter the patient's demographics and personal information. Once this takes place, the patient is ready for the nuclear medicine scan. 2A is the acquisition workstation. The patient's record now can be queried off the work list or scheduler, and the patient study has begun. 2B is the camera. This is where the patient is scanned. 2C, post-processing. Once the patient's scan is completed, the study may require post-processing, and the images and results will be transferred to a reading station, printer, and archival device. Number 3 is the router and hub. The router and hub's main purpose is to allow the data to be sent to more than one place or network. Another word you hear is gateway, which is referring to the router. A gateway allows the data to travel among different networks if there is more than one. The hub and router both allow the data to travel to multiple destinations on the same network. 4A is a reading station. It is a computer used by physicians to interpret the patient's scans. 4B is an archival device, which allows PACS or cloud to store patient data for 5 years or more. Lastly, 4C is the printer, which is used for ACR and ICANL accreditation. Let's take a moment to review some of the terms we have covered so far, but also introduce you to a few other common terms that have to do with troubleshooting in nuclear medicine. A router. This is a networking device that allows multiple medical devices to communicate with each other on the same or multiple networks. A hub. This is a networking device that allows multiple medical devices to communicate with each other on the same network. Gateway. This is a term used when a device like a router connects two different networks, for example, 192.10.100.1 or 10.10.100.1. Host. Host is another term used for a medical device connected in a network. Some examples of hosts are cameras, printers, and PACS. Ethernet cable. This is the type of cable used to connect the medical devices in the network, like a Cat5, a twisted pair, or a crossover. An IP address. Each medical device has an address. For example, 192.10.100.1. AET, which stands for Application Entity Title, and it is a unique name for each medical device on a network. A port number. This identifies the sender and receiver of data on the network, sort of like an area code. And ping. This is a basic computer program that allows a user to verify that a particular IP address exists and can accept requests. We have all seen these messages when trying to export or transport patient data to another host on the network. Whether it's the acquisition station or processing station barking at you, it's a common error nowadays. So what can we do about these errors besides calling the biomedical department or your local nuclear medicine service engineer? Believe it or not, you are the first line of defense in troubleshooting. And just because you don't have a computer background, you have seen this before, and now it's time to do it yourself. To reboot, restart or forced shutdown, whatever you call it, is the most effective troubleshooting method and fix when dealing with transfer issues. A warm reboot is where you restart Windows and it goes back into Windows. This happens when you click Turn Off Computer and then click Restart. The power never goes off on a warm reboot like the cold reboot does. A cold reboot is where you turn the computer completely off so there is no power to the system. This would be the same result as if you pulled the power cord from the system. This happens when you go to the Start button and click Shutdown. This is another effective troubleshooting tip that we just take for granted. Are the Ethernet cables plugged in, or do we have connectivity? Do we have a green light on the Ethernet connection to the PC, or do we have an amber light? A solid green light indicates connectivity and present. A flashing green light is a sign of intermittent connectivity, which is a fancy way of saying 1 minute the PC is on the network and the next it's not. A flashing amber light indicates collisions. You'll see this flash occasionally, even on a healthy network. But you don't want to see a flash so often that it looks like a solid amber light, which indicates no connectivity. How to ping. One of the easiest ways to troubleshoot a Dicom transfer error is to ping the medical device you are sending to. But first, you must ask for a list of the IP addresses that you will be sending to. Once you have a list of the PACS, reading station, and archive server IP addresses, keep it handy near the sending workstation. This is for the Windows-based operating systems only. For example, XP, Vista, and Windows 7. First, click the Start button in the bottom left-hand corner of the screen. Second, click the Run option in the right-hand column. Type CMD in the text box and then hit the Enter key on your keyboard. A black box with a flashing cursor will open. This is the command prompt. Type ping and then hit the space bar on your keyboard. Type in the address you'd like to ping and then hit the Enter key on your keyboard. Then you just wait for the ping results. Look at this screen. What does this all mean? If the ping comes back with a reply, it has successfully resolved the host's address, meaning whatever you were trying to communicate with verified that it made contact. But if the request timed out and it did not successfully resolve the host's address, there was an issue communicating. So when your IT person or field engineer comes in, you can tell them that it will ping but still won't Dicom transfer, and then he or she will probably do a double take. Siemens released the eSoft workstation in the year 2000 on the Windows 2000 operating system. Since then, it has migrated from NT to XP to Windows 7 in 2015. The names of the software have went through several changes as well. Originally, the software was called eSoft and started with version 1.0. and since then there has been around 25 upgrade versions released. In 2015, the most common version was the Symbia.net version 1.0. After exporting, sending, or transferring the patient's data, the workstation gives you an update on the bottom of the screen. This will tell you whether it transferred successfully or failed. This particular error is from a standalone workstation set up on a PAX for this example, and the workstation is telling us that it cannot find another computer in the network. The most important piece of information you see from the status is the computer icon with a line across it located in the bottom right corner. When you double-click on this icon, the Network Job Status queue appears. This is the Network Job Status queue. Anything imported or exported shows up here with details of the transfer. Since we had a line through the computer icon from the last slide, we already know there is an issue with this particular transfer. We cannot transfer another patient until we clear this failed job by highlighting the patient and selecting Delete located below. If the case will not clear or the computer becomes unresponsive, the next step would be to place a service call. Since the year 2003, Philips has migrated from a Unix operating system, also known as a Pegasus, to a Windows-based operating system called the Jetstream Workstation, and most recently, the Extended Brilliance Workspace. Both are Windows-based systems and use a program called Dicom Server to import and export patient data. When a patient is exported to the Jetstream Workstation and the Dicom server is not running, you will get an export failed error on the sending workstation. The Jetstream Workstation has a Dicom server status indicator located on the lower right corner of your desktop. If this says Dicom server stopped, that is probably why the export failed. The Dicom server must be restarted before another transfer can be completed. Go to the desktop and select Utilities from the toolbar across the top of the page and select Startup Dicom Server. Once you have ran this command, you will notice the Dicom server status changes from Stop status to Running status. The export will transfer successfully now. The Dicom server software can affect both importing and exporting data on the Jetstream workstation. GE Nuclear Medicine Workstations on the Accelerus platform allow for quick Dicom transfers through the buttons located in the left corner of the screen. The first button should be set to local, and the second button should be set to the transfer destination. Once an export is active, you will see a small icon below the transfer buttons that update the status. Once a transfer is put into an active state, the Transfer Destination Play button turns green along with the transfer status icon below. If you click on the transfer status icon, you will see the status of the pending transfer. The transfer status screen is split into 3 sections. The top section is active transfers. The middle section is completed transfers, and the bottom section is failed transfers. Once a transfer fails, you may have to clear this before another transfer can be made. Notice the transfer status icon has changed from green to red, and if you hover your mouse over the icon, it will display a message indicating that transfer has failed. At this time, you should go back into the transfer status screen, highlight the failed transfer, and clear it. This will reset the transfer status, and you may attempt another import or export. The Philips CardioMD and Siemens C.Cam are both dedicated nuclear cardiology gamma cameras. They also use the same acquisition software, even though they go by different names. Both systems export data the same way. You select the patient data icon on the left-hand side of the persistence page, and this launches the database. Select the patient name from the top list, or select a single dataset from the bottom list, and hit the Export button on the right side of the screen. This is a transfer failed error from a C.Cam, which is identical on a CardioMD. Depending on the version of software, your patient data may be exported automatically after the study is finished, or you may have to export manually from the database. No matter what method or software version you have, it does not have any bearing on this error. The transfer failed because there is an issue with the network, acquisition station, or processing station. The first step is to restart the camera and acquisition computer. We like to shut down the acquisition computer first, and when the computer is completely off, find the large toggle switch on the camera located on the back about 6 inches above the floor, and turn it off for at least 30 seconds. Once the camera is restarted, go ahead and restart the acquisition computer. Then restart the processing workstation. This could be an eSoft, Pegasus, or Jetstream. Once that is complete, you can then restart the router or hub. A lot of these dedicated cameras use a router or hub to network other devices like printers to make sure we have a green light all around after restarting. On the Persistence page, click the Tools button to access the Calibration and Configuration menu. Select Service in the Calibration and Configuration menu. Enter the service password, DDD, in the Service Calibrations menu, and select Node Configuration. Once the node's configuration page menu is displayed, check for a red X over the Dicom connected station. In this example, a red X has been placed on the Virgo folder to show what this would look like. This is an example of when a service call would be your best option, because if you see the red X on your processing station, it means that there is no connectivity between the camera and processing station. Thank you for joining us today. We hope you enjoyed our imports and exports of Dicom, networking, and troubleshooting in nuclear medicine webinar. The next step will be to take the test. You will receive your certificate once this webinar is no longer available. And thank you so much for participating.